look like this, to look up at that seven. Good morning.
Good morning.
I'm David.
I'm John.
We're here to talk to you today about Hoover Dam a little bit. Now, John, when you work for the Bureau of Reclamation, who owns and operates Hoover, you go down there in the river valley to look at things, and there's Hoover Dam. You don't look like this. You don't look like this. It's too big. You look like this, to look up at that 738-foot tall dam, this massive piece of 400 million cubic yards of concrete that's considered one of the modern marvels of the world.
Absolutely.
It's definitely, I think, one of the engineering marvels of the world.
How often did you get to go
Well,
on any part of the installation?
Bureau does dam reevaluations approximately every 6 years, and so in one of those cycles, I was the principal materials engineer for Hoover.
Dude.
Went out and looked at set the coring up, brought the coring to the lab, tested the coring, those kinds of things. So in that period, I was there, somewhat often, a few times to be out there. And then after 9/11, when we first set up security facilities, security protocols, I had a hand in engineering that process and engineering those standards. So at that time I was out there a few times. And then we used to go
Such a government worker.
and then Boulder City, of course, is the regional office.
Right.
So working in that region, a lot of times we meet at the regional office. So and the regional office is this very nice building, looks down into the lake, it's just a really nice spot. So yeah, I've been there at least a dozen times.
I'm so jealous. I've only been there once, and I tell you, running my hand across the dam as I walked,
Yeah.
between Nevada and Arizona, is that what it is?
Yeah,
That was just a magical experience.
it's a magical place.
Yeah.
It's engineering religion. It is a magical place.
And it's not just, to me, it's more than just the engineering. It's the story behind it, and you're part. I don't know if you see what I see, but you're part of that story. There's a wonderful book by Joseph E. Stevens called "The Hoover Dam: The Great American Dream," or "The American Journey."
Yeah.
And it goes into not only the concrete mix design and the copper pipes and all these other, but the people and the stories behind it. What's the question that people normally ask you when you talk about the Hoover Dam?
Well, they ask me about the size and those kinds of things, and of course, they ask me if there's anybody buried in the concrete. That's probably the question I get the most.
Right, and that's a messed up question, first of all. I don't know, even if it was, anybody would want to talk about that, but what you're talking about when you ask that question, I try to look past the stupidity of the question sometimes. Because what I feel like they're asking about is, what is the story behind the Hoover Dam, the people who helped build it, the folks who first looked at this open, piece of the mountain range and said, here's the mighty Colorado. You think we can tame it with some concrete?
Yeah, you have to put that question into perspective. It's a very important question, really, in the modern context. Hoover built in the 1930s.
Right.
We're coming out of the Depression.
Right.
The country is in terrible shape economically, financially. We've had the droughts. It's just terrible. And so Hoover was part of the projects to bring the workforce back into place, the work camps.
Right. Oh, and those work camps.
To bring the economy back. And yes, people did die.
Sure.
During the construction of Hoover. But that led to safety laws. It led, most of them died from heat exhaustion.
Well, and then there were people who died for hypothermia in the early camps because it got colder than all get out at night.
Yeah. I'll tell you, in that canyon on a summer day, it's hot. It's hot down in the bottom of that canyon. The spray is coming up off the river from the release from the powerhouses. So there is a cooling effect, but even with that, it's hot down in the bottom of that canyon.
Sure.
And so that brought about very important safety regulations. So, it helped the concrete technology, but it helped safety technology as well.
Well, and then you look at the other innovations that came out of, there were very, very aggressive critical paths, time restraints to digging out some of the overflow tunnels and what have you,
Right.
and the methods that they came out with, new types of trucks that had drills attached to them for them to hand drill out the tunnel. I mean, there were just a lot of cool concepts that were created during the Hoover Dam.
Right.
And it's because that we were still under a financial constraint. What were the name of the companies that got, it was like the 6 big companies, or I can't remember.
Yeah, that's true. It was called the Six Consortium, or the six Consortium, something like that. I don't remember all the names right off the top. I'd have to research that.
Yeah,
But you're right. It was a conglomeration of companies. They were thought about building a lower dam, and then they decided to build the higher dam. So,
I mean, just such a history. And what we were looking at that Joseph E. Stevens book today, and we got to this one point in the book where they were, you know, it's not just the size of the dam, but it is the engineering that went behind. Because if you monolithically cast a section of concrete that big, more likely crack from thermal, and that's what we're about to get into.
that's right.
From the increase in energy and heat,
Right.
and then how many, it was 100 years, 200 years for it to actually cool down?
Right, you know, and let's put that in historical perspective. Look at the late 1930s, Abrams Law, the
Right.
water-cement ratio.
Right.
When does that come out?
Well-
Right after the Second World War. So we're 10, 15 years behind what is one of the foundation elements of concrete design today.
Right, so a huge, you know, we talk about innovation today, you know, the 20s and 30s, when it comes to concrete, I mean, the cylinder tests that they were doing, everything that they were doing, the copper piping to cool it down,
Right.
and this is one of the people who made that story possible. I mean, 75th anniversary,
Yeah. Yeah, I think that's right.
we got 7,500 PSI.
Yeah.
Some of the cores.
Yeah.
So I went and I did the tour. I don't know if you've ever done the tour before. You should definitely go see it. We'll put the link below. I asked one of the tour guides, who aren't the best,
They're good people.
you need to hire some other people. These people aren't great. I asked him, so how strong is the concrete? You know what he said?
I did.
Strong enough to hold the water back.
See, that's the perfect answer in my mind. That's how strong it is. That's true. So,
Not good enough for me. But there are some real questions that I have for David, who, you know, was part of that story for 38 years?
I was with the Bureau, 38 years. Yeah.
38 years. So I got 4 questions for David today.
Okay.
Well,
Here we go.
well thought out questions. And no, some of these questions really have been plaguing me. And this one isn't my question. It is something we have talked about before. But let's put it to rest. Is the Hoover Dam a cover-up for an alien UFO?
No.
Extraterrestrial?
No.
Done. I don't want to address that question ever again.
Yeah, might be they all moved to the Denver airport. There's some.
Oh, shit. I guess we're going to be having this
Have this conversation again about Denver airport. So.
One of the things, and I ended up, you know, when we did go to Hoover Dam, Whitney surprised me with it, but I had a bit of allowance saved up, and I ended up buying all the videos that they show at the Hoover Dam.
Bureau appreciates it.
Yeah. And, you know, coins and books and all the videos, when you see them get that crane of concrete, that bucket of concrete,
Right.
and they pull that, you see this fluid concrete that comes out,
Right.
and it looks like the concrete, the workability of the concrete that we use today, but there's something very special about that concrete. And my question requires some definition, so I'll give you time for that.
Okay.
But let me throw my first question out there. How in the heck did they create a concrete with, 1 foot diameter aggregate
Or bigger.
or bigger without causing segregation?
Well, John, you've probably been to the Bureau Reclamation Laboratory.
Once or twice. Love that place.
Yeah, and you've seen the big polished cross sections that are there.
I try to steal them
From
every
the
time.
from the different dams. And a couple of those, if you look real close, very, very close, you'll see that those big rocks had a tendency to drift down just a little bit. And you can actually see with your human eye. You don't need a microscope. You can see that on the very bottom, there's a nice paste, like you would like. At the very top, you can see this more of a ginger ale paste, a little more air in it, because as the rocks sank, it lowered the density of the concrete right above it.
So what does that mean, folks?
There was some minor segregation.
So David accidentally told me that before we started. Blew my mind, and it makes sense.
Yeah.
It makes sense.
And, you know, when you're dealing with rocks that size, I mean, they're just, yeah, they're like here on the table. I mean, you get rocks out of the abutment, you blast them out. And, you know, folks, let's think about this. It's 1930. See if you can think about anything that happened in 1930. We're talking about mules, horse-drawn carts. You know, I mean, it isn't like today where you just zip out there from Las Vegas. That was in the middle of nowhere,
Right.
you know, in 1930. I mean, that was a trip. That was, you know, horseback.
Mm-mm.
Maybe, if you're lucky, ride the train rail out, the
Sure.
working train rail out. So you're not going to be able to haul stuff long distances like we can today. So you rock out of the abutment, rock out of the river, smaller rocks. It's all going to go in the mix.
That makes so much sense.
You know, and the big rocks, we want to fill up the space. I mean, golly, do we have a lot of Portland cement laying around in 1930? I mean, you know, do we have huge bins sitting out in the middle?
What is the Universal Cement Company that came from the East Coast at a certain point, and then they started bringing it west?
Yeah, probably. I don't know that for a fact, but you know, just think about the problems these people had to solve. I mean, this is what some people call real engineering. That you're out there in the middle of nowhere. You got shovels, you got mules.
A lot of people to help out.
You got a lot of people out there. You build a camp, you know, for the people to come work. You know, just the logistics of the town. I mean, you got to have food, sanitary facilities, water. I mean, you know, just the logistics of going out in the middle of nowhere and doing all this is quite a story.
So when we define, it's important for us to recognize why. I just want to bulletize the reasons why we use such big rock. The first one, you said it loud and clear, proximity.
Right.
It's hard, I mean, proximity, and can they really bring crushers out there to do that much work of grinding it down to a smaller 3/4 inch, 1 inch side, which you don't see here.
Right.
Or is there another reason that they use this size aggregate outside of proximity and what they could create?
It fills the volume.
Fills the volume?
Yeah, I mean, that was the thing. It's like any mix design, just like you do here in the lab today. I mean, you want to minimize the amount of Portland that we use for the strength that we need. And why is that? Because what's the most expensive ingredient in concrete in 1930?
Cement.
And what's the most expensive ingredient in general in concrete
Cement.
today? Cement.
Cement.
Same
Makes sense.
Same problem. Same problem to solve in 1930, same problem today.
Did they go after a gradation of aggregate? We drew a representation over here on the board that we're going to use in a second, but did they go after this, what we've created here, almost a gradation of aggregate sizes, or was it poorly graded?
Oh, John, I've heard you tell this story so many times. If I fill this room with beach balls, there's going to be all these voids in there. If I take some of the beach balls out and put in volleyballs, that's going to reduce...
I feel like I'm getting reprimanded.
No, I've just heard you tell this story so many times. Volleyball's out, softballs, less voids. Softball's out, you know, ping pong balls, less voids. Ping pong balls out, sand, still less voids. So the answer is the same then as it was now. You have to fill the volume but reduce the voids.
Wait a second, but that porosity index, that granular skeleton, the gradation envelope, that was something that we lost. That was something that became newer in the late or the early 2000s, 2005 to 2008 timeframe is when people started going back to that gradation envelope.
Right.
So saying today, that's a misnomer. I mean, what do we define as today? If we're going by decades, it was only a decade ago that we were still fumbling around with self-consolidated concrete with one rock and one sand. You know, and there still are people who are doing that. So, you know, what they did at Hoover, I mean, today that is, using the gradation envelope is a very, I would say it's a higher level way of thinking of concrete mix design. What's his name? Tyler Lay.
Yeah.
At Oklahoma State University has something called the tarantula curve.
I don't know this one.
Well, I mean, there's Lisa, there's Emma, there's, I think, his tarantula curve. There's software packages out there. We have our own software package where, you know, based on a certain concrete that we want, a certain K factor, a certain fluidity, we define, okay, this is how much paste we want, and this is the granular skeleton we want with the porosity index that we're designing for. So based on that porosity index, we need to use a certain combination of aggregates that gives us some envelope or gradation envelope of rock sizes.
Right.
So they did that in the 30s, and we're just rediscovering that in the early 2000s.
Yeah, I think that's a fair statement. I mean, let's think about the porosity of a dam. Has to hold water. It has to have very low porosity. So,
It makes sense.
you know, so they were like,
What could we do?
what can I do so this will hold water back? You know, hold 500, 600 feet of water back.
No, it makes sense. So
Yeah.
this representation, we're looking at the second question now.
Right, this is your first question about why did they, about filling the voids.
Right.
Filling the voids. So in the 30s, and in most of my career at the Bureau, we always talked about mass concrete as concrete that was massive. And it had big rocks, and we brought core into the lab. You'd see these football-shaped rocks in it, and much like that. You'd see
Right.
rocks like that in the core. We drill 12-inch core, and sometimes you'd see it go right through a rock. It wouldn't be any concrete, because the rock would be big enough that it'd be as big as the core. So we'd see these shining surfaces of all these different sized rocks in the core when we brought them in. So in those days, in my career, and in my prejudice education at the Bureau, we referred to mass concrete as concrete that was massive. It had big rocks, it had all kinds of stuff in it.
Now, so 1.5 foot diameter, even larger in 1930s mass concrete.
Right.
Mass concrete today, 2018.
Well, there's a link. There's definitely a link to the two. In
Right.
the 30s, we had to deal with heat.
Right.
I mean, there's still this massive amount of concrete. There's still the heat exhaustion from the hydration.
Right.
So it takes heat in to start and puts heat out as it hydrates. So we had to deal with that in the 30s. And as you mentioned, we had copper pipes, we had cooling water. Sometimes they use ice in the mix, and all kinds of crazy things to help control that heat. So in the 30s, we had big rocks and we had heat. Okay. Now today, if you look up the definition of mass concrete today, it says concrete in which you must deal with the heat loss, with the heat of hydration.
Right.
That's pretty much the definition today. So we might be looking at 1.5 to 2 inch,
Not this, none of this.
maybe down to this size. That's a little bigger than 2.
3 inch, 4 inch
Yeah,
diameter.
you're probably looking at 1.5 to 2 inch. I mean,
Wow.
Something like that. But you're still dealing with that heat. You need
Totally.
to deal with that heat either in lifts
Or chemically.
or chemically. Yeah, I can't think of any project I've seen in this century where I've seen cooling pipes. I mean, it's just,
And that's what they used in the Hoover Dam, by the way.
right.
Copper pipes through with cooling water. I don't know if it was, I can't remember if it was ethylene glycol or...
Yeah, in some cases they just use the river water. Some
Right.
cases they had some chillers.
But then they backfilled those pipes with a grout
Right.
after a certain period of time.
That's right.
Right. Wow. So both of them were connected with heat.
Right.
Now, could it be argued that in the 30s, since they didn't have chemical, they were looking for the mass of the rock was part of that mechanism for cooling, or at least something that's not going to generate heat, as opposed to little rocks that are not going to have that mass effect?
I think coincidentally that's probably true. I mean, it's not like they brought rocks out of the freezers or anything like
No.
that.
I'm
Most
not
of them are sitting
suggesting.
out in the desert sun. I mean, it's hot in Nevada in the summertime, in the Nevada desert. But yeah, I think it does probably have a heat absorbing effect. I think that's a fair statement.
Definitely not going to be a heat generating effect after a certain point compared to hydration.
Yeah, I think that's all fair. I've never seen any such calculations. The calculations I've seen
Sure.
were like, I have this 10 foot by 10 foot by 10 foot block and we have to cool it for X number of hours.
Right.
Yeah.
That in and of itself is flipping awesome. I mean,
Yeah, and of course the dam was built in subsequent blocks. So you build a block, build a block, build a block, let them expel the heat, and then you fill in between them.
somebody once told me it looks like a checkerboard.
Yeah, I do.
I think that's putting it down a peg. I think maybe if it was a 3-dimensional checkerboard that went on different levels. I mean, it's like a MC Escher drawing. It's amazing to see the construction of the Hoover Dam.
Yeah, it's like a box of checkerboard fudge. You
Boom.
got peanut butter, chocolate, peanut butter, chocolate, and then you've got, on top of chocolate, you got peanut butter and whatnot.
So you know, we've got a great mixer. I actually had the privilege, the pleasure to work with the folks at the Bureau of Reclamation. I think it was actually while you were still working there. They were making those 3 foot by 3 foot by 6 foot blocks and then pulling cores out of it. And this is actually one of the rocks from the mix design that we were doing. So I obviously never worked on the Hoover Dam. I never worked for the Bureau. Interviewed, but made some dam concrete. Yes, I have. Yes, I have. And hey, if somebody has one of those slices from the Hoover Dam that they're willing to give or sell to us, I want one of those.
Yeah.
Really, I've tried to steal those, and they weigh a few £100 each.
Yeah, they're pretty big.
And I have not been successful. Like, the last time I went there, Brett passed me, he goes, "Trying to steal one of those slices again, hey John." I was like, yeah, not working out. I wanted to bring a dolly one time, but
yeah, it's a little obvious.
Obvious, and then they have security everywhere.
Lots of dresses, movers, steel moving truck, and all that.
Those are some scary dudes in the front office or that front waiting area.
Yeah, it's interesting you should mention those big blocks that were made at the Bureau, John. We got something coming got a future talk coming on that, and the size effective cores.
Oh my gosh!
That's why we made those. So don't forget to tune in at a later time, and we'll talk about those big blocks and what the findings were from those.
It just blows my mind that this is like the gradation, or part of the gradation that they would use.
Yeah.
Blows my mind.
I mean, engineering is part of science. It's also a lot of art. This was big art at that time.
Dude, I would have loved to have been part of that.
That would have been interesting. You know, don't mind living in a tent.
Not at all. Well, hey.
Working behind the mules.
You know, at one point, that town, that camp got built up really nice.
Yeah,
I mean, it did.
That's true.
So, no, I wouldn't mind living in a tent. And if, you know, I spend at least 10 minutes every week trying to figure out time travel. And almost there. And if I can go back in time.
Yeah, that'd be an interesting thing to see. That would definitely be interesting to see.
I did meet a man once who claimed that he was part of the Hoover Dam project. He was a little crazy, but old. He could have been. I mean, who knows?
Possible.
But definitely crazy. So, just cool to meet somebody who said they were.
Yeah, that's right.
Part of it. Anyway, thanks for joining us today. Hopefully you learned something new. If you have any questions, any comments, and concerns, drop them in that area right below. Don't forget to like, subscribe, all that jazz. I'm John.
I'm David.
Thanks for joining us. Go Concrete!
Beat asphalt.